Good morning, girls. How are you? Okay, today we are going to be revising our last lesson, two lessons actually, lesson 20.2 and lesson 20.3, which was talking about the congruency of triangles. And if you remember, I told you that you will be having 4 rules about congruency of triangle. But we didn't have time to only take 2. So just like a hint for the future, actually the 4 laws are the first 2 laws that we already took, ASA theorem, SAS theorem, and then the other 2 laws that you didn't take was SSS theorem. I think it's understandable from the name of the theorem. And then the last theorem is not for any triangle. Actually, this is for a certain kind of triangle, which is the right angle triangle. It's called HL theorem. It's called HL theorem. If we try to explain what are those 4 theorems, the first 2 we already explained, but let's recall. I told you if we have 2 triangles like this, you know that any triangle have 3 sides and 3 angles. When I tell you that 2 triangles are congruent, I mean that all the 3 sides in both triangles are equal and all the angles are equal. These are congruent. To prove the congruency, we have 4 laws. The first law was ASA. ASA means if I have 2 angles in both triangles equal and one included side, it's very important to understand that the side is written in between, not haphazard. No, it's written because it's included between the 2 angles. Where is the side between the 2 angles? This side. So if this side is equal to this side and these 2 angles are equal, so you can say that these 2 triangles are congruent using ASA theorem. If another side was equal, not this one, are they congruent? No, it should be an included side. For the SAS theorem, it was the opposite. This time the angle is included. If I have 2 sides equal, for example, this, and this is equal to this, and then I have this time the angle included in between. Where is the angle included in between? This angle. So this is the angle included in between. So in this case, if I have these 2 sides equal and the included angle are equal is equal as well, so you can say that the 2 triangles are congruent using SAS theorem. For the other 2 rules or theorems that you didn't take, I think it's explaining itself actually. SSS theorem, it means what? SSS theorem mean if the 3 sides in the triangle are equal to the 3 sides in the other triangle, then these 2 triangles are congruent. This is the most or the easiest theorem of all because it's very obvious and it's very proved. If the 3 sides are equal, actually this is the meaning of congruency. So if this is equal to this and this, for example, is equal to this, and this the third side is equal to the third side, so you can say that the 2 triangles are congruent using SSS. One might ask me, teacher, is there AAA theorem? Actually, no. Why? Because if the 3 angles are congruent, this doesn't mean that the 2 triangles are congruent. Why? Let me explain for you. What if I have a big triangle like this? For example, this was 4 centimeter, this was 5, and this was 6. And then the angles here, for example, all of this is examples. This is not true. For example, this was 30, this was like, let's say 70. And let's say that the one up here, 30 and 70, so 80, for example. All of this is for example. And if you try to do the math of 4, 5, 6, this will not be the angles. And you have another smaller triangle. You have another smaller triangle. Let's say, for example, this was 3, or here, 4. This was 3, this was 2, and this was 1. And then you measure the angles, you found it to be 30, you found it to be 70, and you found it to be 80. you will find that the three angles are congruent in both triangles. But actually, is the two triangles congruent? Of course not, because this is 4 centimeters, this is 1, this is 5, this is 2, this is 6, this is 3. So what is the name of this? When the two triangles have the same angles but different sides, those are called not congruent triangles, those are called similar triangles. Those are called similar triangles, girls. Take care. We took this in grade 8. There is a difference between congruency and similarly. Congruence, everything is equal. But when the angles only are equal, but the sides are different, this is called similar triangles. So there is no something called AAA theorem, because the angles might be equal, but actually the sides are not equal. This happens, girls, when you do dilation, for example. When you have a figure and you increase it by 2 or you decrease it by 2, the angles will maintain its measure, but the sides will be different. Understood? Okay. The last theorem is HL theorem. This is for a specific kind of triangle, which is the right angle triangle. This is a theorem for only the right angle triangle. If I have two right angle triangle in front of me, and I know that H, what is H? You know that for a right angle triangle, this is called hypotenuse, and these two are called legs. These two are called legs. So if in two triangles, both of them were right angle, which means I am sure that this is 90 and this is 90. I am sure that these two angles are 90. If the hypotenuse was equal to the hypotenuse and one leg, choose any leg. For example, this leg was congruent to this leg. So I can say that these two triangles are congruent. This is the HL theorem. So the HL theorem is for a specific kind of triangle, which is the right angle triangle, when you are sure that this angle is 90. HL mean if the hypotenuse in one triangle is congruent and equal to the hypotenuse of the other triangle, and one of the two legs are equal, then you are sure that these two triangles are congruent. Understood? Okay. So actually, we explained and re-explained all of the theorems of congruency that you have in triangle. I hope that you understand it. And again, these are very important theorems. Okay, now let's go to our revision sheet that is uploaded on ClassDojo. Okay, let's begin by question 1. As you can see, we have two triangles in front of each other, and he is saying point X here is the midpoint of VZ, is the midpoint of VZ. Before I complete, I'm extracting information. I understood since X is the midpoint of VZ, so I know that VX should be equal to XZ, right? Okay. Can you conclude that triangle VXW is congruent to triangle ZYX? And if so, explain your answer. If there is not enough information, explain what additional information is needed. To prove that these two triangles are congruent, I have 3 laws now. We understood the third one. Either SAS, either ASA, or SSS. SSS, of course, will not help me because I don't have any information about the other two sides. I only know that Vx is equal to xz. So it will not help me. Let's see about angles. Do we know any information about the angles here? I don't know anything about Y, anything about Z, anything about W, anything about V, but it's very obvious that this angle is congruent to this angle using what? Using vertically opposite angle. So I know that Vx is equal to xz, and that angle x from this side is equal to angle x from this side. So I have only 2 pieces of information. Do we know anything else? Actually, no. Do not tell me, teacher, xw is equal to xy. Did he tell you here that x is the midpoint of wy? He didn't. So do we have enough information to say that these two triangles are congruent? We don't have enough information. He is telling you what additional information is needed. For example, using SAS, If he told me that x is the midpoint, so we can say that this side is equal to this side, so SAS, SAS. So using SAS theorem, we can say that these two triangles are congruent. Very well. So here we are going to write that they are not congruent. Triangles are not congruent because this is not sufficient information. We need 3 pieces of information and we only have 2. The triangles are not congruent. What another piece of information? If he says that x is the midpoint of wy, then using SAS theorem, the 2 triangles will be congruent. Okay, let's go to the next question. Okay. Okay, so let's go to question B. Okay, we have 2 triangles, as you can see. We have triangle A, B, C, and triangle C, D, A. And from the drawing, I know that this angle is 90 and this angle is 90 because I have the mark of the 90, the square thingy. And then this angle is 34 and this angle is 34 as well. So these 2 angles are equal and these 2 angles are equal. And can't I say AC is what? AC is the same. AC is common factor between the triangle up and the triangle down. So we can say that AC is equal to AC using the reflexive property. So the 2 triangles are congruent using which theorem? Angle, side angle, right? Did you see? Just from the drawing. I didn't even read the question. Of course, the question will be complete the proof to prove that the 2 triangles are congruent. Okay. First of all, angle CDA, angle ACD, ACD, the 34, is equal to which angle? CAB, right? So here I'm going to write CAB. Why? Because this is given in the drawing. What else is given? The 90 degree. Angle BCA is equal to angle DAC, right? So here angle BCA is congruent to angle CAD. Again given. And what is equal to what? As we said, the side AC is equal to AC. Why? Reflexive property. Okay. So triangle ABC is congruent to triangle CDA using what? Which theorem? Using ASA congruence theorem, or ASA theorem right away. Using ASA theorem. Very easy proof, right? Okay, very well. Let's go to the third question. Explain how you know that triangle ABD is congruent to triangle CBD. Okay, let's see. I have a 61 and a 61. I have a 29 and a 29. And then we have this 11 in here and this 11 in here. Actually, if you try to use, again, if you tell me, teacher, this is equal to this and this is equal to this and this is equal to this is not a theorem. This is not a theorem. Let's find the missing angle. Let's find the missing angle. The 2 theorems or the 3 theorems that we took is either SSS, and of course we don't know SSS here because I only know the 11 centimeter, and maybe that this side is the same, but I don't know anything about this and this. What about ASA? ASA. Yes, we can prove using ASA. We can prove that the 2 triangles are congruent using ASA because angle is equal to angle angle is equal to angle, and then the side is equal because it is the same side. Yani we don't need the 11 centimeter in anything. But by the way, if you try to get the missing angle here, it will be 90 degrees. So using SAS, yani SAS, you can even use it. Using even SAS, yes, without even the 90 degree, SAS right away. We don't need to get the 90 degree. Since this side is equal to this, is equal to itself, and the angle 61 is the same, and 11 is the same, even using SAS theorem, I can prove that these two triangles are congruent. So you can write whatever you please. You can write whatever you want. I'm going to do the ASA theorem. So to explain, I'm going to tell him that angle ADB is equal to angle DBC, and DB is equal to DB because it is the same side, it's common factor between the two triangles. And then the last angle, which is the 29, angle ABD, is equal to angle BDC. So ASA, ASA. So the two triangles are congruent using ASA theorem. You can do as you please. You have all of the theorems, you can do it. By the way, even there was another theorems, but I didn't say about them. There is something called, I think, AAS theorem. You can look it up. Okay, the last question in our lesson. Question 4, it's a proof. As you can see, we have two triangles facing each other. I have ACB and I have CED. Nothing is written here, so you have to read the question. Okay, use the figure to do the two-column proof. The whatever and whatever are whatever over some land. Neither family will be satisfied unless the two triangular fields are exactly the same. And we need to prove that the two triangles are congruent. Point C is the midpoint of the two intersecting segments. What does he mean? Let me increase the size. Point C is the midpoint of the two intersecting segments. Where is the two intersecting segments? AD and BE are the two intersecting segments. If C is the midpoint of both, he means what? He means that this side is equal to this side, and that this side is equal to this side. Yani C is the midpoint of AD, and C is the midpoint of BE. Very well. And of course, I know that angle C is equal to angle C using vertically opposite angle theorem. So of course, the two triangles are congruent using which theorem this time? SAS. SAS. Okay, so now we can write the proof. Let's write the proof together. Okay, C is the what of what? C is the midpoint of what and what? Of AD and BE. Why? Because this is given. Okay. So AC is equal to CD, and what? And BC is equal to CE. BC is equal to CE. Definition of what? Definition of midpoint. So AC is congruent to CD, and BC is congruent to CE. Actually, I don't think this is needed. Okay, so in here you are going to write BC is congruent to CE again. Definition of congruency. I don't think that this step is needed, but because we are completing the proof, but they are equal already. Okay, definition of congruency. And ACB is equal to is congruent to angle what? Congruent to angle what? Yes, ECD. Using what theorem? Using vertically opposite angle theorem. So what will be congruent to what? The two triangles will be congruent. Using what theorem? Using SAS congruency theorem. Very well. We finished our lesson and we finished our syllabus, girls. Congratulations. And I hope it was a good year for you and that you learned something. And I hope to see you in the near future, inshallah. If you have any problems and any questions about this lesson, about the previous lessons, about anything in mathematics, you can contact me right away. Thank you and goodbye, and see you